Hi to the host students, it's Mr. Kaczynski, and I've got the solutions to the 8.7 practice your skills. Let's go. Without using a calculator, oh no, evaluate the expression b squared minus 4ac for each of the given values, then check your answer using a calculator. Okay. B squared minus 4ac is an important one. It tells us a lot about a quadratic equation, so I think that's why they have us focusing on this. So let's do it here. B squared minus 4 times a times c. Well, let's see. B squared, 5 squared. Now let's do this here. B squared, and we'll do a in purple, and we'll do c in green. How about that? So B squared, it's going to be 5 squared minus 4 times a, which is 3, times c, which is positive 2. All right, so 5 squared is 25, and 4 times 3 is 12, times 2 is 24. That's 1. Boop, boop, boop. Let's check it. Let's do 5 squared. Really should use parentheses, I guess. 5 squared minus 4 times a times c. Boom, boom. There we go. 1. Got it. All right, good. Let's do it again. This time, let's use more mental math, shall we? I think we shall. So let's do b squared. Negative 3 times negative 3 is 9. Minus 4 times a times c. Let's see. A is 1. C is negative 3. 1 times negative 3 is negative 3. So this is really 9 minus negative 12. 9 plus 12. That's what that says, which is 21. Let's check it. Let's go. B squared minus 4 times a times c. Got it. 21. Do it again. All right. B squared, negative 6 squared is 36, minus 4 times AC. A is negative 2, C is negative 3. Negative 2 times negative 3 is 6. So this is 36 minus 24, which is 12. All right, so let's do that one on the calculator. Let's do B squared, negative 6 squared minus 4 times A, which is negative 2, times C, which is negative 3. Did I do it right? I did. I got 12. All right, and one more. B squared, 9 squared is 81, minus 4 times AC. A is 9, C is 0, 9 times 0 is 0. 4 times 0 is 0, so this is just 81. Let's do it on the calculator. B, which is 9, squared, minus 4 times A, which is 9, times C, which is 0. Boom, 81. Got it. All right, for each equation, identify the values of A, B, and C. All right, let's do A in green, we'll do B in blue, and we'll do C in pink. Here we go. All right, so A is 2, right there. Boop, boop, boop. B is 3. And C, what did I do that? Pink. Yep. C is negative 7. Cool. All right. Now this one, here's the problem. This is not written in general form. So we got to go x squared plus 6x. We got to add 11 to both sides equals 0. Okay. Now we can see that A is 1. We can see that B is 6, right? And we can see that C is 11, not negative 11. All right, I think I'm gonna be done with the highlighting and the color coding, okay? Let's just get after this. A is negative 3. B is negative 4. And C is 12. This one, let's rewrite it in general form first. It's negative 4.9x squared plus 47x plus 18 equals 0. That's called general form. We got to go, oops, that should be x squared. So we got to do the x squared term, then the x term, then the constant. All right, so we now know that A is negative 4.9. We know that B, what am I doing B in? B is 47. And we know that C is 18. This one is not written into general form. We got to write it into general form. How about negative 16x squared plus 28x? And then when I subtract 57 from both sides, 10 minus 57 is negative 47. And that'll leave 0 on the right. So now we can answer this question. A is negative 16. B is 28. And C is negative 47. Okay, a few more. Oh, that's not general form. So we got our 5x squared. We got a negative 2x, and then I got a 4x over here. So how about we subtract 4x from both sides? That's going to be negative 6x. And then we also have the 7 over here on the right of the equal sign. When I move it to the left of the equal sign, it becomes negative, like I subtracted 7 from both sides. So there we go. And now we can identify A is 5. B is negative 6. And C is negative 7. And just a couple more here. Yep, that is not general form. So let's start with the 5x squared. That 3x is over on the right of the equation. Move it to the left. It's going to become negative 3x. You got that negative 4 right there. There we go. That's balanced or written in general form. A is 5. B is negative 3. And C is negative 4. Oh no, this one's a mess. It's going to take a couple steps here. I'm going to distribute first. 3 times 4 is 12. 3 times negative 5x is negative 15, or negative 5x squared is negative 15x squared. So that's distributive property. Now I want to get rid of the 5x and the 1 that are on the right. I want to move them over to the left. So let's start with the negative 15x squared. That's our x squared terms. I see the 2x there and the 5x there. 2x minus 5x is negative 3x. And then I see the 12 and the 1. 12 minus 1 is 11. And that gets rid of everything over there. Okay. So our A value is negative 15. Our B value is negative 3. And our C value is 11. There we go. Of course, you can pause if I'm going too fast. Solve each quadratic equation. Which equations can you solve readily by completing the square? Which equation has no real solutions? Okay, I want to answer this question first. Which equations can you solve readily by completing the square? I don't think I'd do this one because it's got a lead coefficient other than 1. I don't think I'd do B because it's got a lead coefficient other than 1. I think this one can be done by completing the square. I don't think I'd do this one with completing the square. This one, that's no lead coefficient other than negative 1. I'm going to use the zero product property when I get to that one for sure. So I think just C is the one. Which one has no real solutions? We'll get to that when we get to it. For this first one, I'm going to use the quadratic formula. X is negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I'm using an algebraic method to do this, I could graph it, and I'm going to graph it to check it. But if I'm using an algebraic method like factoring or square roots or completing the square, I'm going to use the quadratic formula here. Let's do it. So what do we got here? We got x equals, the b value is negative 3. The opposite of that is 3. Plus or minus the square root. Again, b is negative 3. So negative 3 squared is 9. Minus 4 times AC. Let's see. A is 2. C is 4. So A times C is 8. All over 2A. So 2 times that 2 is 4. All right. What's that get us in the square root sign there? 9 minus 32. Oh boy. Again, 9 minus 4 times 8 is 32. Yeah, that gives us a negative number, right? Negative 23. So this one's got no real solutions right there. No real solutions. So if we graph that, it's gonna, I should have graphed it first probably, right? But whatever, we need to make all these connections. So let's see, 2x squared minus 3x plus 4. This is not gonna ever touch the x-axis. There it is. All right, let's try the same thing on this one. Okay, so let's write it into general form. Negative 2x squared plus 7x minus 3 equals 0. And I say we use the quadratic formula. Let's go x equals negative b, negative 7, plus or minus the square root of b squared. So b squared, 7 squared is 49, minus 4 times ac. AC, negative 2 times negative 3 is 6, all over 2a. 2 times negative 2 is negative 4. So I'm going to get rid of these two negatives. Like a negative over a negative is positive anyway, so we don't need negatives in both places. So let's go 7 plus or minus the square root. 49 minus 24 is 25, okay? All over 4. And the square root of 25 is 5, so let's go 7 plus or minus 5 over 4. 7 minus 5 is 2. 2/4 is 1/2. And 7 plus 5 is 12. 12 over 4 is 3. There we go. I feel like we almost did that one in notes. Let's go graph this thing. So we got negative 2x squared plus 7x minus 3. And we're going to graph it. Yeah, trace it. 1/2 is one of our roots. Boom, 0. 3 is our other one. Yep, 0's out as well. Okay, so we use quadratic formula for those two. This one, can we do it with factoring maybe? I mean, we said completing square, but are there factors of negative 8 that add up to negative 6? No, there aren't. It can't be done with factoring, so I'm not going to do that. Let's go complete the square. Let's do it. X squared minus 6x equals 8. So we're actually like taking this out of general form. And then to complete the square, we're going to add half of negative 6 squared to both sides. Half of 6 is 3. 3 squared is 9. So that's what we're going to add to both sides, right? Okay, this isn't looking too bad. We did that so we could write this left side as x minus 3 squared. It gives us 17 on the right. Take the square root of both sides, plus or minus the square root of 17. Add 3 to both sides, 3 plus or minus the square root of 17. That wasn't so bad. Could I use the quadratic formula with a value negative, or a value of 1, b value of negative 6, c value of negative 8? Yeah, I could have. I kind of like completing a square, especially when the lead coefficient's 1. Let's graph this thing and see how it works. X squared minus 6x minus 8. Graphing it. Tracing it. 3 minus the square root of 17. Is that one of the roots? It is. 3 plus the square root of 17. Is that one of the roots? It is. Okay, great. This one, I'm going to use the quadratic formula. 3x squared plus 2x minus 6 equals 0. Where did the minus 6 come from? I subtracted 5 from both sides, and negative 1 minus 5 is negative 6. All right, quadratic formula time. Again, negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, let's roll. Negative b, negative 2 plus or minus the square root, b squared, 2 squared is 4, minus 4 ac. 3 times negative 6 is negative 18. All over 2a. 2 times 3 is 6. Great. X equals negative 2 plus or minus the square root. Let's do this on the calculator. 4 minus 4 times negative 18 is 76. That's an irrational number. So it can be simplified, but I don't feel like getting into that at this level of math right now and with how much time we have left in the year. So let's just leave it at that. Let's go back to our calculator. Let's graph it and see if we're right. 3x squared plus 2x minus 5 minus 6. We're going to see where that equals 0. Tracing it, my numerator is negative 2 minus the square root of 76. I got to close my square root sign, close my numerator, divide it by 6. Yes. Let's do the other one. We got to do numerator in parentheses, negative 2 plus the square root of 76. Close off the square root, close off the numerator, divide by 6. Got it. All right, just a couple more. Oh man, look at, there's no x term. There's an x squared and there's an x. Let's just add 12 to both sides, divide both sides by 3, and take the square root of both sides. Boom. Graph it. Clear. 3x squared minus 12. Graph. Where its roots? Negative. Uh-oh. Kaczynski, you're going too fast, buddy. Square root of 4 is 2, not 4. What am I doing? All right, there. Negative 2, positive 2. Trace. Negative 2, positive 2. That's why we check our answers, people. Check your answers. All right, last one. X is negative 2 or 3. 3 minus 3 would be 0, right? Negative 2 plus 2 is 0. That's called the zero product property. I'll prove it to you. Clear it. Negative 2 parentheses x plus 2 parentheses and 3 minus x in parentheses. Graph it. Yes, negative 2, positive 3. There they are. Trace negative 2 and positive 3. Man, I used like every method. We used graphing. We used zero product property. We didn't use any factoring. Oh, I'll tell you what. I'll use factoring right here. Got you. 3 times x squared minus 4 equals 0, right? And then I can factor that x squared minus 4. That's x plus 2 times x minus 2 equals 0. And then I can use the zero product property, and it's positive or negative 2. There you go. I use some factoring. The only other ones that are factorable is B right here, and I ain't about to do that. So that's all I got for you. See ya.